Hello students, in this video we discuss experiment 6 in cycle 1. Design a 16 to 4 priority encoder using two 8 to 3 priority encoders. Aim of this experiment is to design a 16 to 4 priority encoder using two 8 to 3 priority encoders. Apparatus required for this experiment are trainer kit, patch cords and power supply. Before going to start experiment, once let me recall what is a priority encoder. A priority encoder provides n bits of binary coded output representing the position of the highest order active input of 2 power n inputs. If two or more inputs are high at the same time, the input having the highest priority will be taken precedence. Let us start with 4 to 2 priority encoder. This is how truth table will look like. So this is 4 to 2 priority encoder. Number of inputs will have 4, number of outputs equal to 2. Outputs have been given like y1, y0 and inputs d0 to d3. d0 is LSB bit and d3 is MSB bit. So for LSB bit, 2 power value will be less compared to the MSB bit. In the same way, if you see the 2 power value also, this will be 2 power 1, this will be 2 power 0, 2 power 1, 2 square, 2 cube. Depending on the priority of the 2 powers, that corresponding output will be coded here. For 0, 0, 0, 0, we'll have don't care condition. For 0, 0, 0, 1, as it is related to D0, we'll get output as 0, 0. And next possibility is 0, 0, 1. This can be a don't care, either 0 or 1, but priority will be given to highest order bit. That is, this is 2 power 1, no? So this bit will be given priority. So it will be output is 0, 1. And for this 0, 1, don't care, because even if it is 0 or 1, even if this is 0 or 1, priority will be given to highest active input of 2 power n. So this is the highest active input of 2 power 1. So the output will be 1, 0. And next, the last combination, if here we have 1, if the other inputs are either 0 or 1, priority will be given to highest order active input of 2 power 1, 2 power n. So you can see here output 1, 1. And in the same way, we can see 8 to 3 priority encoder. This is the block diagram of 8 to 3 priority encoder. Number of inputs equal to 8, D0 to D7, and outputs, number of outputs equal to 3. Truth table for this can be written as D0 to D7 and outputs Y0 to Y2. And D0 is LSB bit and D7 is MSB bit. For the initial case, if all are zeros, output can be anything. Don't care is it can have any output. Let us start from here. For 0, 0, 0, 0, 0, all zeros, and if it is 1, output will be 0, 0, 0. So here, wherever you have 1, the highest order priority of 2 power n will be taken into account. So here we have 1, here we have 2 power 1. So output will be 0, 0, 1. In the same way, here 1, whether it is a 0 or 1, whether it is a 0 or 1, priority will be given to highest order 2 power n. So this will be taken into consideration, D2. So we can have 0, 1, 0. And in the same way, we can see all other cases. Okay, next coming to 16 to 4 priority encoder, number of inputs equal to 16, D0 to D15, and outputs we have 4 outputs, Y0 to Y3, and D0 is LSB bit, so this is LSB 0. D0 is LSB bit and D15 is nothing but MSB bit. LSB bit, MSB bit. Initial, if all are zeros, we'll get output as don't care condition. And in order to fill this truth table, let us start 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. Then output will be 0, 0, 0, 0. Okay, because starts with 0, 0, 0. And next, all zeros. If you put here as 1, and this can be a don't care, either 0 or 1, priority will be given to highest order 2 power n, because here 2 power n will be 2 power 1, this is 2 power 0. So this will be given priority. So output will be 0, 0, 0, 1. If you take next case, don't cares, 0, 0, 1, 0. In this way you can fill all the cases, okay, till you reach 0011, till you reach all ones here. The last case will be 1, don't care, don't care, don't care. So you can see all don't cares. Okay, so if you fill the truth table, the truth table will look like this. You can see this is LSB bit, MSB bit, and outputs here it has been written like Q0 to Q3. Okay, in trainer kit we can see one more pin on the trainer kit, that is enable input. We have to keep it low in order to make this operation successful. And we have a limitation of a trainer kit, like in theory we just see like this is a don't care condition, but in trainer kit if you put this as once, then only we'll get the corresponding output. You please make a note of this when doing the experiment. This cannot be a don't care when you are doing the same experiment on the kit. It should be once. Okay, so that is what it has been shown in the manual. This is LSB, this is MSB. You can see this. If you note it down, you'll understand this. Okay, let me show you the connections. This is a 16 to 4 priority encoder using 8223 encoders. This is one 8223 encoder and this is one 8223 encoder. And you can see 16 here. For this 8223 encoder we have 8 inputs: I1, I2, I3, I4, I5, I6, I7, I8. Okay, and for this again we have 8 inputs: I1, I2, I3, I4, I5, I6, I7, I8. Okay, the outputs of these encoders have been given to these NAND gates internally, and out of this we'll get 4 outputs: y0, y1, y2, y3. Let us make the connections. So for 16 to 4 priority encoder we should have 16 inputs. We take 8 inputs from one 823 encoder and we take 8 inputs from this 823 encoder. Let me show you the connections. I1, I1, I2, I2, I3, I3, I4, I4, I5, I5, I6, I7. Inputs are being given to logic switches, which you can see on the kit. I8. 8 inputs have been given from this encoder. Next 8 I am giving. That is I1 of this encoder, I2 of this encoder, I3, I4, I5, I6, I7 and I8. Total 16 inputs, 8, 8. And you can see outputs. Y3. This is Y3, Y2, Y1 and Y0. And you can see one pin here, enable input. Okay, this enable input has been given to ground. Okay, these are the connections for 16 to 4 priority encoder. Let us verify the truth table now. You just switch on the trainer. This is LSB bit, this is MSB bit. In the truth table we have written like D1 to D0 to D15. So you can consider here also D0 to D15, D0, D1, D2, D3 and so on. According to truth table, first thing is 0. If you take the first case, if this is 1, you will get 0, 0, 0, 1. Next, if this is 1, D1 is 1, you will get the output. So as I said just now, if you apply don't care, you have to get the output. That is, this bit can be don't care according to theory. But in this kit, if you put this as 1, then only you can see you are getting the output 0, 0, 1, 0. Next, that is what it is going to take. Highest priority will be given to priority will be given to highest 2 power n input. So this is 3, so you are getting 0 0 1 1 3, and this is the fourth input 0 1 0 0, fifth input 0 1 0 1, sixth input 0 1 1 0, seventh input 0 0 0 triple 1, eighth input 1 0 0 0, ninth input 1 0 0 1, 10 1 0 1 0, 11 1 0 1 1, 12 1 1 0 0, 13 1 1 0 1, 14 1 1 1 0, 15 1 1 1. So in this way you can verify this priority encoder.